what the stock image off the ECU is set to, which is fine. We have no need to change that. What you might change in the MUT table specifically is 2-byte load, possibly 2-byte airflow, and possibly some other features if you're having trouble with one aspect of your tune and you need to start logging something, say MyVec intake cam advanced position, if you need to log some other attribute of the ECU that it's just not set up to log by default, you're going to define it in the MUT table. So understand, when you're changing these values, all you're doing is changing what it is that you can log with a data logger. You're changing what addresses the logging program will be able to gain access to. Now when I say 2-byte load, you may not know what that means. You may have heard it, you may know exactly what it means, but I'll assume that you don't know what it means. If you remember on our high-octane fuel map, we had load along the x-axis. And again, this was also on the timing map, and it's on several other types of maps as well. It's a very important concept in tuning, especially with turbocharged, supercharged cars, because engine load represents airflow, it represents boost pressure or vacuum. So if you want to be able to fully tune your car while it's under boost, which I will assume you do, you're going to need to understand load, and you're going to need to understand 2-byte load, specifically as it relates to the Evo. So by default, from the factory, there is no value in the MUT table that will efficiently allow us to data log what the engine load is at any given time. So we run into the problem of the car knows how much load the engine is under, but if you were data logging it with EvoScan, there is no address in this MUT table from the factory that represents that load accurately. So there is no possible configuration in EvoScan that will allow us to log load accurately. The only way we can do that is by coming into the MUT table, making changes to allow us to gain access to these other addresses in memory to log them with EvoScan. And the reason we call it 2-byte load is because it's obtained by logging 2 separate bytes and combining them to form the one load value. Now, the reason we do that is because in decimal form, 1 byte represents the values from 0 to 255. And because the ECU is granular enough to see load in very small increments, even increments less than 1, it doesn't really do us any good to only have 255 values. You can tell even from the factory our load scale goes beyond 255. It goes to 260, 280, 300. And if you have a high horsepower car, you're probably seeing loads higher than 300. So 1 byte, while it represents values 0 to 255, doesn't efficiently represent all the possible load values that the ECU could be experiencing. Now, there is an exception to that, which I'll get to in just a moment. But for now, assume that 1 byte is just not enough to log load. So it was determined that by changing 2 MUT table addresses, we can actually log 2 separate bytes and interpolate from them what the true load value is. We can actually log the values from 0 to 255 twice, and the first value will give us any number from 0 to 255, and the second value will give us a multiple, giving us a very, very high maximum possible loggable load with 2-byte load. So now we've basically removed the cap. 255 is no longer a cap. We can now log several, we can actually log 255 times that amount, which is great. So in EvoScan, you're going to see a request ID, but you'll actually be able to go in and edit the EvoScan XML to see what the second byte is in 2-byte load. So let's take a look at the EvoScan XML. That's stored under the program files, EvoScan, whatever version EvoScan you use, data settings, and data XML. Again, if you're tuning Evos, you're going to really have to love these XML files. You'll probably be seeing them a lot. So this defines all the different aspects of EvoScan. We look down to our Mode 2 data list items. What we'll find is I've defined a row here for 2-byte load, and I'm going to log request ID 00 and request ID 01. That corresponds to MUT00 and MUT01 in the MUT table on my ROM. Now, as it is from the factory, MUT00 and MUT01 are not the correct values for me to log load, or log 2-byte load. So as I said, what you're going to need to do after you've got your MUT table defined is you're going to have to change these, and you'll change them depending on what people have discovered the proper address is for 2-byte load in your ROM. And again, you'll change these by hitting the equals sign. Now, you'll notice that there's a description here that you can enter hex values by starting with 0x. So try to remember, if you're not entering in a decimal value, if you're entering in instead a hexadecimal value, always prefix it with 0x. So if I was to change this to 6A22, for example, I would type 0x 6A22. And you'll see that value will change. So now when I log MUT00 with EvoScan, I'm going to be logging a different area in memory, and it'll return a different value. So if you're having problems with EvoScan logging data that just doesn't seem right, either your request ID in EvoScan is pointing to the wrong MUT table address, or the MUT table address is pointing to the wrong ECU memory address. One or the other. In most cases, you'll find that the MUT table hasn't been updated to point to the appropriate memory address.